All right. Okay. I think is it turning on? Looks like it, yeah. Okay, so last time we saw sequence and series, and we saw had a lesson on sequence and we had a lesson on series. But today we're going to look at a special type of a sequence and a special type of a series. So I'll give you its name. Let me write that a bit clearer. Arithmetic progression. So by arithmetic progression, I call it AP for short. So we have arithmetic sequence, and we have arithmetic series. Yeah.
Is it connected?
Yes. Yes. Small little English point. I don't know how true it is in every English-speaking country, and I can just tell you based off my experience with my math teachers, but arithmetic is actually a noun and an adjective, spelled the same way, nearly, but I mean, we pronounce it differently if we're using it as a noun or as an adjective. So as an adjective, it's arithmetic. But as a noun, we say arithmetic. I don't know if anybody knows this word. Does anyone know arithmetic? Yeah, what does arithmetic mean? It's adding, isn't it? Arithmetic means to add. So arithmetic as an adjective, it must have something to do with adding. And it does actually. So let me show you what arithmetic is. An arithmetic sequence is something like this, etc. We make the next piece by adding 2 in this example. This is what I mean by arithmetic sequence. An arithmetic series would just be the same thing, except we add the numbers, and each time we increase by, in this example, 2. Oh yes, but now, I made it. But now I'm going to build more on it. So once you have these words, we can go down to looking at special formulas for these types of problems. Okay, can I scroll down? So the idea with an arithmetic sequence is we start with a number, and then we add a number to it, and then we add the number again, and then we add the number again. So this is what's happening each time. So in my last example, we started with 3, and then we did plus 2, and then plus 2 again, and then plus 2 again. This A is called the first term, and the D, which we add each time, that's called the common difference. So in my my only example I gave you today, what is the common difference? Well, that's 2. And what's the first term? 3. In the example I gave you, the first term, 3. So, first example is you want to check if something like 0, 4, 8 is arithmetic? Well, the check is simple. You see if the difference between the numbers is the same. So what's the difference here and here? 4. And then the difference here and here is also 4. So therefore, it is arithmetic. And if it wasn't the same, if the next time you add 5, then it's not arithmetic. It's not AP. So this is how you can check. It's a very simple way to check. Okay, I can scroll down? Yeah. So let's make a general formula here. So last time we saw a general formula and we had a recursive formula. So let's see if we can make a general formula here. So if I go back, I'll go down. So you notice that the first term is A. The second term is A plus D. The third term is A plus 2D. And the fourth term, A plus 3D. So it should be clear what's happening here. If you want the nth term, that is A plus, yes, n minus 1D. So this is our first formula for today. We will have 2 formulas for today. This is the first one. So let's look at some examples of using this formula. What is the nth term in minus 9, minus 14, minus 19, etc. So we know what the first term is, we know what the second term is, and we know what the third term is. So let's find out what the nth term is. So we need 2 pieces of information to use the formula. To use the formula, we need to know what the A is. Well, that's clear. The A is minus 9. And we need to know what the D is. Well, that would just be minus 14 minus 9. So the difference here is minus 5. So we have the A and we have the D. So I can now use my formula. UN is A plus n minus 1D. That is A plus n minus 1D. That is A plus, well, actually, minus 5n plus 5. So I have UN equals minus 4 minus 5n. And this is the answer. So you could check that it works. If you put n equals to 1, you get minus 9. If you put n equals to 2, you get minus 14. If you put n equals to 3, you get minus 19. Which are the 3 numbers that they should be. So you've made a formula to find any term. You can find the nth term with this formula for this example. Okay? And you sometimes get this in the exam. It's not so long to do. Let's look at a more difficult one. How many terms are in 9, 18, 27, ... 1, 2, 6. So I know there must be, of course, at least 4 terms because I can already see 4 of them. But I know that there's much more than 4 because I start at 9, 18, 27, etc., 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 and I finish at 126. So my question is, how many terms do I have? Well, this one here is the first term, this one is the second, this one is the third. This one we don't know what number it is, so I will say it is the nth term. The way to find out what n is by using this formula. un equals a plus n minus 1d. And that is the nth term. So that means here is 126 equals a plus n minus 1d. But I can find what the a is. This is the a. And I can find what the d is as well. So I know that a equals 9 and d equals 18 minus 9, which is 9. So far. So if I use those numbers, 126 equals 9 plus n minus 1 times 9. I get 126 equals 9 plus 9n minus 9. Well, that's great because they will cancel. And then I can divide by 9. So I get n equals 14. 14? So there are 14 terms in this sequence. Okay, we got that yet? Okay. Next example now. Okay. Example. The 7th term is minus 13. Minus 13. And the 17th term is minus 23. So just to be clear, what I'm saying is the 7th term is minus 13 and the 17th term is minus 23. So my question is, find A and D. Okay, so let's have a look at this one. Everything I need to know, I get it here, and I use my formula. The 7th term is a plus 6d, and that should be minus 13 from the formula. The 17th term is a plus 16d, and that should be minus 23. And you got it, because we did this last week. What method will I use to solve this type of problem? Yeah, elimination. Cancel A's. So here I'll get 10 if I minus them. Minus 13 minus 23 is 10, isn't it? They go. And then that's minus 10d. So then what does d equal? Minus 1. And I just put that back in here. And I'll get a equals, let's see, it's minus 13 plus 6. Minus 7, is it? Yes. So just to be clear, all I'm using right now is just this one formula. Every question I've done so far I just need that one formula for all the questions so far. Now, in a moment, we'll have a look at the second formula for today, because I said there are two formulas. So this formula is for arithmetic sequence. So, of course, the next formula is for arithmetic series. Okay, I have to scroll down now. So this is an arithmetic series. A plus D plus A plus 2D, etc. A plus n minus 1D. So what I have here is the sum of the first n terms. First, second, third, etc. nth term. So my question now is, can I find a simpler formula for this type of problem? In other words, could I have some formula that lets me quickly add all the terms together? Well, of course. So let's have a look at finding this formula. What I'll do is I'll write this again, except I'll just write it in reverse order. Yes, that's how we do this proof. A plus n minus 1d plus etc. etc. plus a plus 2d plus a plus d plus a. Yes? Did I do this right? Yes. Okay. Now, what I'll do is I'll add the two lines together. So on the left I'll have two sums. Now something interesting happens here. If I just open this bracket for the moment, I'll have A plus ND minus D. Now when I add these two together, what happens? I get 2A, don't I? I get 2A plus n minus 1d, because that's still the same. Now what about, for example, if I add, say, this one and this one together? Well, here I have a plus nd minus d, and then I add it to a, so what do I have? 2a plus n minus 1d. If I add this with this one, I get this. Likewise, if I add this one with this one, I also get this. Now, I hope you've noticed that they're the same. And that's very, very important. It actually turns out, every time I add them together, I'll get the same number. So all of these pieces, they're all the same. Now this is perfect, because it means this big formula, I can make it really small now. Because if you just think about it for a moment, if I go to the side, if I have something like 4 plus 4 plus 4 plus 4, they're all the same. How many of, plus 4, how many of them do I have? 5. So the answer is just 5 times 4. So if I go back here, how many of these blue pieces do I have? Oh, you do know. You do know. No. How many do I have? I have n of them. Because remember, first, second, third, etc., etc., nth. So I have n. N is a number, my friend. Still a number, though. For example, I don't know your name, so I call it X, but I know it's still a boy's name. You know, so it's still a number, I just don't know what it is, but it's still a number. Okay, so this means I can change this into n, multiply 2a plus n minus 1d. And with just one step left, I have my formula. I have Sn equals n over 2, 2a plus n minus 1d. This is the formula. Now, I'll show you how to use it now in a moment, but this is the formula. So, I'll leave this up now. Just let me start my program here. Okay. So this formula allows you to quickly calculate long arithmetic series. Do you remember in the last class you had to use your calculator and you had to calculate each piece and add it together? We don't have to do it anymore for these types of problems. So let me show you with an example. So my first example is I have 40 terms. So n is 40. Yeah. If you did this on your calculator, it would take a long time to do, right? Yeah. And I tell you that the 40 terms are, I start with 8 plus 11 plus 14, etc., 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 all the way to 125. So just a moment. So I'll go back here, don't worry. So I start off with 11, and then what was my next term? It was 8 plus, what do I need to add? 3, isn't it? So what's after 11? 14. Now when do I stop?
1 to 6. 1 to 5. 1 to 5.
Keep going. There, 1 to 5. So let's see for ourselves what answer we should get. We should get 2,660 when we add all these numbers together. So let's see if I can do that. What's the first term? 8. D, 3. N, 40. Let's put those numbers into my formula. So I get the sum equals 40 over 2,
8.
Yes?
Plus 40 minus 1 times
3. So that would be 20, 16 plus 39 times 3. That's 20 times 16 plus 90 and 27, 117. Is that right? 90 and 27, yeah, which is 20 times 117, 127, 137, 134, 133. Is that right? Yeah. Okay, let's see, that's 2660. Look, no calculator, and I added them all up. 2,660. Same answer. So it's a very convenient formula. Let's have a look at more examples of this formula. Can I scroll down? Look, you don't need to write all this down. I just didn't have a calculator. You can just go straight to the number at the end. Oh, I told you 6, yeah. Okay. Scrolling down. Right, let's have a look at another example. So, what is the sum of the first n terms in 5 plus 13 plus 13, 5 plus 13 plus 21. So in this example, I don't tell you how many terms there are. I just say there are n terms. But we still use our formula to calculate the total. The total is n over 2, 2a plus n minus 1 times d, which is 8, isn't it? 8. It looks like we add 8. Oh, yeah, that's it. N over 2, 10, plus 8n minus 8. That's n over 2, 2 plus 8n. And what's nice is I can cancel in the 2 to make a 1 and to make a 4. So I get Sn equals n, 1 plus 4n, which equals 4n squared plus n. This is the simplest I can make it. This is the answer. If I put n equals 2 into my formula here, what number do I get? 2 squared is 4, times 4 is 6, oh sorry, hang on. Start again. 2 squared, 4. 4 times 4, 16. 16 plus 2, 18. If I add the first two numbers together, what do I get? 18. Now, if I put n equals 3, 3 squared is 9. 9 times 4, 36. 36 plus 3, 39. Do I get 39 if I add the first 3 together? Let's see.
Yes.
I do. Yeah, I get 39. So you see, this formula can tell me the total for as many numbers as I wish. And I just showed you it working for the first, second, and third. So it will work for the first 100, whatever you want. Okay, write that down, and then we'll go to another example. Okay, scroll down. Yeah. Okay, so next example. No, I'll give you a different verb. Compute. Okay, so here it looks very, very similar to an example I did a few minutes ago, but there's one big difference. There's one thing I don't know in this problem. What is it? The n. I know the a, I know the d, but I don't know how many numbers I have. But earlier today we saw how we can find the n. Huh? Say again? Yes, of course. Oh, I remember. Oh, yes. My memory's not that bad, don't worry. I'll tell you when you need to worry about me. It's not yet. So we start off by saying un equals minus 113. What's the a here? Minus 8. And the d? Minus 3. So now I have a plus n minus 1d equals minus 113. So minus 8 plus n minus 1 times minus 3 equals minus 113. This is really good because now I can find my n. I have minus 8 minus 3n plus 3 equals minus 113. Minus 3n equals minus 113 plus 8 minus 3. Minus 3n equals minus 108, is it? So I can divide by minus 3 and I get 36. Is that right? Students with calculators, please.
Yes.
Okay.
Minus.
Yes. Yeah, minus n value would be really bad. Really bad. Also, what would be a bad n value to get?
Decimal.
0 would be very bad, a decimal would be very bad, and a negative number. Because what type of number should n be?
Real number.
Not real? Well, it should be real, but more specifically, natural number. Natural number. Okay, now we have the n, we can use our formula. So S36, we have 36 numbers. N over 2, 2a, what was our a? 2a plus n minus 1 times d. What was d? Minus 3. Alright, so that's 18 minus 16 minus 105. That's 18 with a minus, minus a 1, 21, isn't it? One. Hang on. No, I can do this. It would be 2, 4, 2, 0 minus 2, 4, 2. Two, 2188? Ah, so close. 2178. I was trying to do it too quickly. All right. What? I failed. Okay. Minus 2,178. Okay, 2 more examples to do. Can I scroll down? Yep. Okay. So for this one, find A and D if the sum of the first 19 terms is 228 and the sum of the first 22 terms is 297. So to be clear, what I'm saying here is the first 19 terms is 228 and the total for the first 22 terms is 297. Yes. Okay. There are many ways to do this one, and in fact there are quick ways and long ways to do it. I'm showing you the long way because it will work for all the different types of problems you have. But if you just think about this for a moment, you might be able to figure out different ways of doing it. But I'll just do it the safest way. So we know that the sum of the first 19 terms is 228. So I can say n over 2 2a plus n minus 1d equals 228. And likewise, n over 2a plus n minus 1d should equal 297. So it's very similar to earlier today. I just need to clean it up. So if you take out your calculators, and if you could multiply this by 2 over 19, and multiply this by 1 over 11, or 2 over 22, can you tell me what you get? So I have 2a, oh, I'm sorry, wait, I know what the n is here. Let me add that in. 19 and 22. Okay. So I have 2a plus 18d equals, so what's this number, please? Thank you. And I have 2a plus 21d equals, great. So we're ready to go. Elimination away. Cancel 3d equals 3, so d equals 1. Put that back in here. And I get 2a plus 21 equals 27, so a equals 3. So I have my a and d. Okay, scroll down. Last example. Find x if 2 plus 9x, 3, and minus 4 plus 6x are in arithmetic progression. So what I tell you is these three numbers, 2 plus 9x, 3, and minus 4 plus 6x, they're in arithmetic progression. What that means is they make an arithmetic sequence. In other words, this number I can make it into 3 by adding d, and this number I can make it into this one by also adding d. That's what I mean by arithmetic progression here. Okay, so then how does that help us to find x? Well, if you think about it, this number minus this number, what should that be? 3 minus 2 plus 9x. What should that equal? That should be d, shouldn't it? It should be d. And then what about this? Minus 4 plus 6x minus 3. What should that number be? D. You had a 50-50 chance, you guessed wrongly. It should be d also. So I have minus 4 plus 6x minus 3, that's also d. So if this is equal to d and this is equal to d, then they should be equal to each other, because they're both d. Of course, yes. So you get 3 minus 2 minus 9x equals minus 4 plus 6x minus 3. 1 minus 9x equals minus 7 plus 6x. So 8 equals, 8 equals, am I right? Yeah, 9x plus 6x, 15x. Did I make any mistakes there? I feel like something went wrong here.
No.
I wrote the question down wrong. That would do it all right. Okay, I'll just try and fix this here. No, actually, it doesn't matter. It just be. This is my example. Yeah, my example. But I'm not finished explaining it the first time. X equals 8 over 15. So, if these are in arithmetic progression, it means that this number minus this number should be D. All the way back at the start. This number minus this number is D. 2 in this example. 7 minus 5 is also 2, the D. So it's still true at the end of the lesson. This number minus this number should be D, and this number minus this number should also be D. So I can say this here should equal this here. And solve for x. Now we take our calculator and we can see the sequence at the end. You could put x into this and you'd get your 3 numbers. And you could see that they're arithmetic. But the question doesn't ask me to do this. But if it did ask me to do it, I just put the x in at the end and I have my 3 numbers. So, let's just do that to finish. If I put in x here, can you tell me on the calculator what you get? I know the middle number is 3. So what do I get, please? I'll just wait until someone types it in. Minus 19 over 5. And then the last one? Look, you have it.
Last minus 19 over 5.
Thank you. And the first one? 34 over 5. Are you all sure? Look, you shouldn't be making a mistake if you have a calculator in one hand and... Oh, never mind. Well, maybe I was going to say this, but I decided best not to. Has more than one person checked this? Is it right?
No, the last line is minus 4 over 5.
I guess we know who has a calculator in one hand and not something else in the other hand. Yeah. What is it?
Minus 4 over 5.
Thank you.
No, it's minus 4 over 5.
Are we sure?
Minus 4 over 5.
Yeah.
Stop. There's no minus 3.
Not that I don't trust you or anything, so... Okay. So, what? Oh, it's, why would you ever think this? Yeah.
Okay, 3.
Huh?
3.
No, all. Let's see. How many times do you have off now? Come on! Okay. I've already done the A in each one of them, okay? So B, C, and D in each of them. B, C, and D. Except for the last one, of course, where you have to do A, B, and C, because I don't have the A there. So, in question 1, 2, 3, 4, 5, 6, 7, 8, do B, C, D. But in number 9, do the A, B, C.
For the question, this is
Which question?
1, 2, 3, 4, 5, 7, 8.
Yeah, B, C, D. And 9, A, B, C.
Yeah.
And it's a good question in the exam. And the reason it's a good question in the exam is because the question will only be like this and then that's it. When I was making this worksheet, I tried to imagine all the different possible ways you could have this question. And I cannot think of any other ways to have this question asked, okay? So by doing all of these questions, or all the different types, you really have a good picture of what it will look like in the exam. It can't really be much different to this. Alright. Okay, we're finished there, so. Oh yeah!